the number part, 10, 40, and 50. 10 will be the GCF. What about the x? X to the third power would be the 1, right? Okay, so that will be the GCF, the greatest common factor, 10x to the third. And then 10x to the third times what will give you 10x to the fifth, it'll be x squared. And then 10x times what will give you 40x to the fourth, that would be 4x. It's okay, just 4x. I hope you're okay with that. And then 10x times what will give you the 50x to the third, that will be just minus 5. Are you okay?
Mm-hmm.
Okay, now continue because you can. They want you to complete. You want to factor each polynomial expression completely if you can. So this one, keep the 10x to the third, but this can be factored. Now, I don't remember helping you with the factoring. Do you think you can do the try and error, like by basically just go ahead and guess the combination? Do you think you can do it? For example, the first and the last. The first must be this. The last must be that. Now, I think you may want to try it if you don't know it, this particular method. It's actually taught the two ways, the grouping, like the X thing, or this way. Watch. Let's try it this way.
Do the X.
Okay. Okay, let's do the X. I think the top will be -5, right? The bottom will be 4, I think. That's how you do it, right? Sometimes they put X or something. Okay, then you have to come up with the two combination that will give you the product that will give you -5, but the sum or the difference will give you 4. So likely 5 and 1, but then you have to think, hey, which one gets a negative? This one. Is that okay? To get you 4 when you combine them. -4 plus 5. There you go. And then you can write them out like, hey, it doesn't matter, -1 here plus 5 there, and that's it. Yeah. And then you can check them if you want, like to foil it. You can probably mentally do that. Okay, good. Same with this one. Now, this may not be fun if you try to do the X. It will take a while. Let's try. Let's see if you're going to be okay. Let's try it this way. Let's see if you can go along with me here. The only way you can get the first x to the second power is 5x times x, or x over here, then 5x over there. Now, the last, you have a couple combination, like 9 and 1, or 3 and 3. Imagine that, right? So let me see, for example, if I do 9 over here and 1 over here, the outer, that's pretty big, like 45, but I have to combine to get the inner, I have to combine to get an 18. No, so therefore no. But what if I do a 9 here and a 1 there? Out here, 5, in here, 9. If I combine them, I'm not going to get 18, okay? But then what about 3 and 3? I'm actually doing this on purpose to exhaust the combination. You see, like the last, you have to get 9. So I'll do 3 and 3. That's the only last, believe it or not, this is the last combination you can get. Therefore, it's going to work, but then we have to check the sign. Okay, so 3 and 3, for example, outer, I'll get 15x, inner, 3x. See that? I can get 18, but you need to get a -18. Therefore, they both must be negative. You see that? Mm-hmm. So this is it. This is going to be your combination. Yeah, if you do X, it will take a long while because you have to group them and then factor, the combination. Mm-hmm. But if we have time, I like to come back for it. But maybe that's the way you understand best. But if you see what I did there, I think you could probably pick this up. Yeah, good. Now this one, you have to use a formula. There's 2 of them for the sum of cubes. Do you have that down? If not, I'll write it out. Okay, I'll write it out here because this is the sum. I'll do the difference too. A to the third, B to the third. The formula goes like this. If this were plus, this will be plus. A plus B. And then it'll be opposite. I think they use SOAP. You might remember something about that.
Yeah.
This will be A squared. There'll be opposite here, minus AB. And then plus B squared. The last is always plus. So something like this. Here we go. S, same. Oh, sorry. I'm coming from here. Same, opposite, O, always plus on the last one, O piece. Let me see. S-O, yeah, AP. This is O, AP. The last one here, SOAP. And then there's a minus version also, if you were to be given that. This one could literally be a minus, no kidding. It's exact same numbers, but you will get a minus between them. Therefore, it'll be same minus here, opposite here, a squared plus ab, and plus again, always plus the last one. There you go. This is my a here. You recognize this, right? Sometimes they use x and y, but I think they should not use x and y because you'll be doing x and y for the actual problem. Okay, so it's going to be the first one here. You want to rewrite it so it looks a to the third, b to the third. To do that, you're going to have to kind of see it this way. What times what will give you 27, the same number? 3. Here we go. This is how you're going to get your a. Your a is exactly 3x, all of it, 3x together. So that will give you 27 plus 1 to the third. I'll parenthesize that too. You don't have to, but so what that means is that your a will be 3x, your b will be 1. Okay, and then you can use the top one here. Okay, so here we go. So I'll even write it side to side here. I'll rewrite it even. Actually, no, I'm going to go ahead and do equal here. Pretend this is like right here. And then I'll continue. I think I'll continue like right there. Here we go. Here's the same right here. This will be plus right here. Same right here. Your a will be 3x. Let me be neat here, sorry. 3x plus 1. That's your b. I hope you're okay.
Yeah.
And then the trinomial here. So a squared, that's going to be 3x squared, or 3x times 3x. That's going to be 9x squared. And then minus a times b is 3x, a and b here, 3x times 1, therefore it stays 3x. And then last, well, the plus first, last b squared, so it's 1 squared. B squared is 1 squared, so 1 squared is still going to be 1 times 1. So there you go, that is your final answer. Now, you don't have to show you this, but you should, to get your a exact b, to get it to work out nicely. So yeah, this is your final answer only.
For the 9x squared, when you do, it's a squared, right? So you squared.
Yes, I'll show it
3x.
Here. Yes, this will be 3x
so then
squared.
How is the squared still there?
Okay, let me show you. Are you okay if I were to show the work, it'd be like this, like a 3x squared. Is that okay? You see that? So I took the whole a, the 3x, and then I square it because the formula says that I need to do that. So if you do that, if you remember, there's two ways of doing it. You can give it up like 3 squared or x and then x squared, or you can do it like the long way, 3x times 3x. That's why you get 9x squared. You see that? That's my writing. I hope you're okay with that.
That makes sense.
Yeah, either way. Yeah, either way. Yeah, this is exponential rule that you can do also. Like give up the exponent, the 2 to the 3 and the x, or just go ahead and multiply them out expansion way. Okay, this one. Now, it'll be the difference of squares. So let me do the a and b again. So there is no plus version here. So you have to think this formula to get this one to work. So it's going to be something like this, plus or minus. It doesn't matter which one first. So I think you probably recognize this one. So minus first or plus first does not matter. But I hope you can read that. It looks okay. B. You can have a minus here first if you want, and then a minus here. Okay. So the difference of squares, there is no plus. There'll be no plus. You cannot use a plus one. There is no such formula. Okay, this one you cannot do a and b right away because there is no, for example, 50. There is no one number type itself, right, to get 50. So that is a hint there that you cannot do that. So therefore, you want to pull out the GCF, which is 2, and then you can see your b can be now 5. See that? So that's the next step. That means that 2 will be carried all the way through with all the factors that you're gonna about to do. So now we can do the formula. I think you can tell that 25 is 5 squared. That is your b, and x is like your a. Here's your a and here's your b. You see that? So therefore, I think you may not even have to think that. I think it's recognizable to you. Something like this, 5 and x minus 5. But you see the perfect square number, but it has to be a minus to be able to factor. So there you go. Your final answer with the 2 in the front. Okay, there you go. All right, this one. Now, see, this is a perfect example of why you may not want to do that x thing. If you do the x thing, you have to, it's tremendous here. It's quite a bit of work because now I can't say that. Do you want to see me do the x thing with it? But it's going to be a grouping. but I'll do two ways quickly. I'll do two ways. First, I'll do the guessing, the try and error. It's actually more common in college, by the way. Your teacher, I promise your teacher would do exactly this and not the X thing at all, ever, when he was in college, because there's no time for that. So let me go at it right now. For example, I'm going to do the combination. Now, how do you know what combination to use? It's the first and last, right? You want to do the numbers closest to each other possible before you do a 49 and 1 or 9 and 1. You want to try those first. I know I was doing 3 and I was doing 9 and 1 on the last one, but I did that on purpose to exhaust all the combination. But this time I'm going to go at it like as an educated guess. So there's a thing that from experience, and there's studies on this too, but because of how they write the problem. So anyway, I'm going to go at it. For example, the two numbers close to each other for 49 will be 7 and 7, and then x and x. And then the 9 will do 3 and 3, hoping this will work. Now, the percent of this one is like 70, 60%. It's still higher than 50. So let me see. If I do the outer, 21x, inner, 21x. So I'm right. It's done. You see that? So this is the right combination. You see why this is so good? All the students who actually move on from the x, when they get comfortable, they always do this. They never actually do x ever again. So yeah, so here it is. So this is the combination. You see why? Because if you FOIL it, you'll get your 42. The outer, inner, outside, inside, it will give you 42. So that's done. But watch, I'm going to do the long way. You're not going to like it. But anyway, the answer will be this or this squared. Like that. See?
Yeah.
So either one. Actually, they're both acceptable. Now, if I were to do the long way, watch this. You're not going to like it. You have to multiply 49 times 9. Watch. I'm not going to finish it, but you'll see why you not want to do this. This is called grouping. You remember you have to A and C. You have to times the A and the C. So let me punch in the calculator here. Times 9. It's 4, 4, 1. And you have to come up with the combination that combines like the product of two numbers that will give you the product of two numbers that will give you 441, and then the sum to give you 42. That will take you forever. That's why you don't want to do that. So I think you can see that, but that's not even done. Once you actually figure out the combination, you have to spread it out 4 terms. I know you might remember there's 4 terms you have to spread out. This one you get to the answer right away. So I highly recommend you do that. When we have time, I'll come back to it. Watch. It's not even done. Once you get the combination, not done. You have to write it 4 terms like that, like this one. Oh yeah. So that's the thing. Anyway, okay, let's continue with this one. Okay, this one. It's likely that they already gave you the proper order. Now, if you cannot make this work, what will happen? All you need to do is switch this to inner one. But I'm going to go at it right now without switching. Let's take a look. So this is called grouping that you're about to do. When there's 4 terms, you're going to do a grouping method. So the way you do it, sometimes they do this weird X thing, but let's just do it clean. You're going to factor the first 2 and then ignore the first 2, and then you're going to do the last 2. Watch. This is how the textbook does it. And don't do the parenthesis thing. You'll see why it's clean. It will look weird when you do that. And sometimes even textbook does that. It's not good. But watch. Let me do it. Okay, ignore the last 2 entirely. Pretend you're just going to factor the first 2. All right, so it's the common factor is x squared. You can see that. And then x squared times what will give you 3 x to the third. There will be 3x. I think you're okay with that. I know it's pixelated. Let me be neat here. And then x squared times what will give you x squared back. So it's a plus 1. And then you're done with the first 2. So pretend that that's done. You could even kind of divide the two, the 2 terms there. And then, ignore that. Pretend you do a brand new problem. So like this. Okay, here we go. So the common factor here, including the negative, if this is the negative, you do a negative right away. So a negative 9 is a common factor, a negative 9. Negative 9 times what will give you 27x. So it's 3x. And then you think, negative 9 times what will give you a negative 9 back. So it has to be a plus 1, not a negative 1, right? Yeah. So because you distribute. So there it is. Now, if you actually come back and look at all of this must match. If they don't match, you switch this around and then redo it. Okay? If they don't match, redo that. But I'm glad. Normally they would do it exactly the right order. They will give it to you. So here it is. Now you can write 2 ways. But you have to write this one time. It depends. You want to write in the front or the back. I'll write in the front. It doesn't really matter. So write in the front one time. It's like you factor it out. And then the last one will be this 2 combined. The x squared minus 9. That's it. So this is the pattern if you want, but there's reason behind this. It has to do with distributive property of, but it's a big A though. This too is a unit. So sometimes students get confused here, but you can memorize the pattern. Every time you see this pair being exactly the same, pull it outside one time in the front or in the back, and then write this two together. That's it, in the parenthesis, somewhere in the front or in the back. And then continue if it's possible. This is possible. And here's why. Based on the last one, because you can continue further. So it will look like this. Be x plus 3 this has to do with perfect square, the difference of squares, and x minus 3. You can do minus first if you want. So this will be the final answer. So this here, this last one is the difference of squares. So I'll kind of point it out. A squared minus b squared formula equals a plus b, a minus b. It does not matter which one first. Okay, I think you got this. Okay, continue on. Here we go. Number 7 is a concept. So it's about completing the square. To do that, the way that you do it is this. Now, I need space, but I don't want to intrude into the bottom here. So what you do is that you take the b. Now, if you recall, there's a form that goes like this. Let me write it up here. Ax squared. It's called quadratic. It's a general form, standard form, general form of a quadratic. It looks like this: b plus c equals 0, like that. But you don't have to worry about the 0 part. So I think you recognize this. So therefore, a is 1, b is negative 12, c is what you're trying to find. But the completing the square process goes like this: you take the whole b with the sign and all, divided by 2, but let me go ahead and write it somewhere over here. So you take the b, I'll write the formula. Actually, I'll write the formula. So you go something like this. You take the b divided by 2 and then you square it. Just think that right now and then get the answer and then we'll go from there. So this is how you start completing the square. Let me write it. You can copy this down to make note, okay? Complete square. So this is completing the square process right here. Okay, so I'm going to do it right here. B will be negative 12 divided by 2 and then square it. Now, before I know you can mentally do this, but I'm going to simplify it because it will be helpful for the next step. So it'll be negative 6 squared. I think you can see that. And then this will be it. Whatever this is, you're going to put it here. So it'll be 36. Always plus 36 because when you square it, it's always going to be positive. It doesn't matter if it's the b being plus or minus right there. So it'll be 36 here. So that is the answer. Now, then you have to, for the first part, then you have to finish it by factoring it. So I'm not going to put in the blank yet because when you factor, normally it'll be a square form, but I'll go ahead and do the one before. So when you factor, the easiest way, you don't have to break your head over at all for this one. You don't have to try to actually do that guessing method or the x method at all. How? Well, you write x and x here, and this is the answer. That's when you have to simplify this part, but don't mentally crank out the answer by squaring it yet. Like kind of write in steps like this, and it will save you because this is the answer. It's minus 6 and minus 6 every single time. Yeah, but you got to clean it up. If it's reducible, you got to clean it up. Yeah. So then you write the final answer, the x minus 6 squared. Now, if you don't write the square and leave it as the factored form like that, your teacher will take it. Does not matter. But there you go. Yeah, the minus 6 before you square it will be also part of the second part of the answer. Yeah, no kidding. There you go. So that's how you can do it. There you go. Okay. All right, moving on. Wow, there's so many concepts here. Okay, this one. Are you okay with this one? Okay, number 7? Yeah?
Yeah.
Okay, good. Number 8. So it's a new concept here. It's imaginary. So there are four, I guess, terms you have to memorize if you can. The first one is or 4 things you're allowed to write in imaginary form. Let me show it to you. So I is equals to negative 1, root of negative 1. I think you've seen that, but you're only allowed to write the I, but I'll come back to that. I squared, it's the same thing as I'll write the whole thing. It's the same thing as, I'll write it this way. You can copy this, but you don't need to know this part. You can memorize the last part here. So the same thing as, you square the I and you get a negative 1. So if you ever see I squared, you're only allowed to write -1. If you see I, you keep it I. You ever see I, you keep it I. So you're allowed to write I and -1 when you get I squared. Well, anyway, let me continue on. I'll summarize this. I to the third. I to the third. You need to know I to the first to I to the fourth. But let's see. So I to the third is the same thing as I times I squared. Therefore, it's going to be, if you know I squared is -1, therefore it's going to be I times -1, therefore it's a negative I. But I'll summarize it in a second. So you're allowed to write negative I when you see I to the third. Last one, I to the fourth. Now, your teacher may not actually show you any of this except the summary. I'll show you the summary in a second. Or if you don't have this down, there's a shortcut, and I'll show you when I do the actual work, and you probably rather do that. But I believe this will kind of help you at the same time. So it's the same thing, I squared times I squared, therefore it's -1 times -1, and therefore it's +1. Now, to summarize all of this, if you see I, it's really coming from here. But normally you don't write the root -1, you write the I. Normally you see this and then you make it into I. So the only thing you're allowed to write is this, I squared. If you ever see I squared, you write -1. I to the third, you write negative I. You can memorize all of this, negative I. I to the fourth is going to be 1. That's it. Now, using this, I guess you can think of it like the rule. You can now solve it. Now, to do this, the easiest way is this. That's all you need to do is like this. You divide 4 into 67. And the remainder is the answer. I'm going to show you a shortcut, and I'll show you like the long work. But the only thing you need is to write this part here. I'll show you that too. But I'm going to show you why, and then I won't do it for B. I'll just write the answer. But okay, let me show it to you. So always divide by 4. This one I'll even set it up right now. Always divide it by 4. The exponent when you have I. So anyway, divide this by 4. Get the remainder the best you can. Get the remainder. That's the answer. But you have to write as the exponent, the I to the remainder. Okay, let me do it first. So it'll be 4 one time, and then subtract, you get 2, bring down to 7. 4 can go into 27. Let's see, what is that? 6 times. Because if you do 7, it'll be 28. So 6 times. So it's 24. The answer is the 3. The remainder is 3. So here's, I don't want to intrude into it. Let me go write it smaller here. So it will be 4 here, subtract, you get 2, 7 right here, and then you do 6, you get 24, subtract. The answer is this right here, but you can't write 3, okay? The answer, you have to write I to the third. Now, I don't think you need to do this ever. Here, I will show you why that works, okay? It's I to the fourth to the 16. If you multiply that, and then times it to the I to the third, it will give you the I to the 64. I know this is small. Oh, it's not even, you can't even read it. So it's I to the fourth raised to the 16. That's how this works, where this number came from. Then times the I to the remainder, which is 3, like that. So anyway, and then if you continue, this will be 1 right here times I to the third. So anyway, you don't want to do this. Forget this. All you need to do is this is what you need to do. Get the remainder, do long division, and write it I to the third. And if I to the third, if it's actually simplifiable from here, you have to write, see, I to the third, you're not allowed to write. You have to write negative I. So here's your final answer, equals negative I. Is that okay? Every time you do long division and you get a remainder, even 0, I'll show you. Hopefully it's 0. Yeah, it's going to be 0 here. Watch. You will write I to the 0 power and then see what happens. So this is going to be the answer here. But it's going to fall into one of these every single time because you're dividing it by 4. Here, let's take a look now. This one. 4 can go into 25 times, 20, 20, and then go ahead and, subtract, and then we'll go and bring the 0 down. Then 4 can go into 0 times, so it's 50. So let me show it to you right now. There is no, the remainder is 0, right? The remainder is 0. Are we okay? You still have to actually find the remainder. So the key is to get the remainder, even if it's 0, even if it can divide into it evenly. So here's the answer without this step at all. So if I were you, I would ignore it because it's probably a lot of thinking. All you do is write I to the remainder. So I to the 0, but then you have to kind of look at it. What can I do with that? Can I continue? If it's continuable, then you have to do it. So I to the remainder is 0. Anything to 0, the answer is 1. See that? Anything to 0 is 1. Now, let me summarize. If you actually, every time you work through this and you get I squared, let's just pretend the remainder is 2, right? Then you go over here, it's going to be negative 1. If you and you did the same thing and you get a remainder of 3, like this one, then you write I to the third. And then you look at this here, it's going to be negative I. Is that okay? Like that. Yeah. If you get 0, or if you actually, I'm sorry, let's do remainder of 1. We haven't, pretend you got a remainder of 1. Let's say you get a remainder, you write I to the first power. Then what is that? What is the answer? It's I to the first power, therefore it's I. You're allowed to leave it because of that. The one I circled is what you're allowed to leave. There you go. I to the first is still I. I'm sorry, I hope you can read that. Yeah, I meant I to the first here. Yeah, so these are the possible remainder only. There's nothing more because you're dividing it by 4. And all you need to know is these 4. And you wonder why not 5? Because if you do 5, 6, it will repeat this thing all over again. That's the reason behind it. Okay, if you ever wonder why. But anyway, the remainder is key. Divide the exponent when you do I to whatever power. Get the remainder and write I to that remainder as the power. And then look at is it one of these? If it is, you have to simplify it. That's all. Okay, let's continue. All right, this one, 9. X and y-intercept. Are you okay? You doing okay? We can do. I'll do another one. I'll do another one.
No, I remember those pretty well from the.
Okay, good. Okay, good. I think I might have gone over this with you. Okay, x-intercept, y-intercept. There's different ways to do it. On the table, for example, if you do x-intercept, I'll label it x-intercept. A lot of students tend to memorize it this way. If you do x-intercept, your y must be 0, and then you solve for x. If you do y-intercept, your x is 0, your y is what you're solving for. It's like the opposite. You can think of it that way. The reason behind that is that when you have a graph, if you're finding the x-intercept, the line goes through right there. You don't know what x. Let's pretend you're solving for it. You don't know what x is, but you know your y is 0, x comma y. For the y-intercept, if you go through there, your x is always 0 for y-intercept here, but you don't know what your y is. So that's the reason behind the chart here. And then when you solve, so for example, they ask you to find the x-intercept. So the x-intercept means that your y must be 0, and then solve for x. So let's do that. Like do the opposite. So x-intercept. So you do x-intercept. So do x-intercept first. X-int. So you substitute y. Don't forget your f of x is your y. I think you're okay. This is your y. So your y is f of x. So therefore make it 0 and then solve for x. So I'll copy the whole thing and I'll solve. That's 27. Okay, now you could actually put 0 back here if you want, but I'll make a direct substitution, the exact same arrangement, so that it's easier to recall how I did it. So I make y equal to 0 here. Are you okay? Like I'm following this rule, and then solve. Subtract both sides by 27. So if I subtract both sides by 27, that's 27. You get a negative 27 over on that side, and then you have negative 3. All that still left, like that. To get to x, you have to divide out the negative 3 first. So divide both sides by negative 3. Sometimes they bar the whole thing, but you can only cancel out the negative 3. And then copy what you have left. Over here will be 9 times. Positive 9. Okay, almost done. If you remember, if you try to get, it's this rule right here. I don't know, your teacher might have done something that I'm not allowed to do. It's like you square root both sides. Remember something like that? In high school, that's what they do. But in where I come from, where I work, I'm not allowed to do that. But when you do that, right, if you do something like this, you have to do a plus or minus on the other side, the side that's away from the x. Get it? Like you got to do it like that. So therefore, I don't like to write that, but I'll pretend that I pretend I did that. I don't know how to explain it. I'm not allowed to do that where I work. So I'll go ahead and I'll do a red color. So I did. Yeah, I'm not supposed to do that. It's not correct, by the way. In higher math, I guess you can think, okay, I'll do that. If you do that, pretend I didn't do that, okay, but you can do that. In high school, everyone does that. Your teacher included. So, okay, so if you continue, it will look like this. The plus or minus become plus or minus root 9 is plus or minus 3. But the root of, the root of anything squared, you will drop the base without the square. You remember something when you have root x, it's equals to x. It's actually more going on, like an absolute value, but don't worry about that yet. But yeah, so this is the reasoning. But it's not x only, it's x minus 4 as the base, so you have to drop the whole thing. Okay, we're almost done. Then from here, solve for x, add both sides by 4. Add both sides by 4. I recommend you put the 4 in front of the plus or minus. So add both sides by 4. So here's the final answer. You got 4 plus or minus 3 equals x. It's cancel. And then you evaluate what are those x's are. There's 2 of them, right? One is x equals 4 plus 3, which is 7. Sorry. Oh, wait. I can erase that black bar there. Sorry. Oh, no. It's because it's layered. Oh, actually, I can do it quickly. This one, yeah. There we go. Okay. So, hope you follow so far. So, yeah, you got 2 answers coming. X equals 4 plus 3, then x equals 4 minus 3. So the first one is x equals 7, and the second one is x equals 1. So those are the x-intercepts. You got 2 x-intercepts coming because it's a quadratic. I think you can leave the answer like that, or you can write it as a coordinate, like points. So it's like 7 comma 0, and you got 1 comma 0. So either way, okay? So it's your teacher might prefer one over the other, but at least you got to the x equals 7, x equals 1, you should be fine. Okay, now continue here. Use it without the calculator. Oh yeah, don't forget, you gotta fill it up here. Sorry. All right, number 10. Okay. Now, number 10, it's related to this right here. This one right here, the I. Mm-hmm. So let me break it up. So if you were to do this, if I show you all the work, it will look like this. -1 times 50. I mean, you can shortcut this, then I continue. It will be root of -1 times 25 times 2. You could write 2 times 25, it doesn't matter. Then I'll split them up. A root of -1 times root of 25 times root of 2. You can skip some student can actually go from here to here, or I'm sorry, some student can go from here to the answer. But let me continue. Say, based on the rule, and I is equal to root -1. So you're gonna have to use I here. So it will be I times, I hate the dots. It could look confusing because the I has a dot also. So times 5 times root 2. You okay? See? The root 2, you don't simplify, and I know you know that. So let's rearrange it for the final answer. They normally write the 5i root 2. You can put the I way in the back, but don't put it underneath the root. So here's the final answer. Had you left it here, you should have been fine, but I think the teacher want you to write 5i, something I root something. So in computer, not textbook though. The textbook will write exactly like this. But in computer, let's say online, they might actually write the answer looking like this. Check it out. Like the number first and the I comes right after. Like they have to make sure it's outside the root. Kind of put it to the side. So either way. But this one is most preferable right here. Okay, next one here. You okay with that? I think. So this here also you're about to get I squared. That's why you have to know at least the first 2 here. Yeah, the I and the I squared. I think you know that already. I think you recognize it. Okay, FOIL it. I'll do the whole thing. First is 2 times 2, which is 4. Outside or outer, it'll be plus 6i. Inside or inner. Inside or inner, that would be a negative 6i. There's a shortcut here because there are difference of squares, but some student hardly do the whole thing. Minus 6i. That's my I, okay. Then last, negative times the positive is a negative. Negative 9i squared. Are we okay with that one? Then we'll clean this up. 4, stay 4, but this 2 cancel. They're inverse of each other, the additive inverse. So they cancel out. So you're left with just 9. But I would actually do simultaneous work here. 9 times I squared. I squared is negative 1. So I'll write it as a rule here. It's from that short 4 i's. So it's negative 1, then continue. Then you get 4 plus 9. And your answer is 13. Final answer.
Yep.
Yeah, double check here. Yeah, looks good. Okay, yeah. All right, continue. Okay, this one. Distribute the negative in and rewrite. The front, you don't need to keep the parentheses because there's nothing to distribute in, so just write it without. But then the last two, distribute the negative like negative 1. You can think of it like negative 1. So negative 1 times negative 7 is a positive 7. Negative 1 times negative 6i is a positive 6i. And then continue, combine like terms. So I think you may have recalled your teacher want you to write a plus bi, the complex form, like that. So you want to write the number part first and then the I part after. So the number part will be 10 because 3 plus 7. And then the I, a negative I and a 6i, that's a 5i plus 5i. So here is the final answer. Yeah. You okay with that?
Yep.
All right. This one. Next. Continue on. Oh, I did that 9, I think. I kind of copy overlapping. Yeah, I did 9. Okay, check the intercept. Oops. Oh, don't tell me the layer I'm on. Yeah, it has to do with the layer. So weird. Okay, so check. All right, this one. Oh, I did that. Okay, last. Here we go. This one. Yeah. Yeah, we have time. I can actually show you the long way, the x of the other one. But this one is again a 4 term. You would do the same thing. Ignore the last two. Pretend you split the first two, last two separately. So I highly recommend it. You don't have to parenthesize anything. It's clean and it's actually a more textbook like. So let's do it. So yeah, ignore the last two. Just do the first two. Here we go. I'll block it like that. Okay. The common factor for the first two is x squared only. Oh man, the zoom in. The more I zoom in, the pixelated it gets. I'll try my best here. X squared. Wait. Let me. Yeah. Wait, a little bit here. Okay. The first two, x squared. Parenthesis x squared times what will give you 2x to the third. It'll be 2x. And then x squared times what will give you 5x squared. So it's just plus 5. Okay, right there, close parenthesis. And now pretend it's brand new. Ignore the first two. Ignore what you did, and then just go over here. The last two. If the third term, the third term here is negative. Is a negative number. You factor out negative. So you have to factor out negative anyway. Negative, what is common? Is it 6?
Yeah.
Or is it? It's actually, it could be 18. Let me use a calculator. Now, if you don't get it the first time, then you're going to go back and do it again. Let me see. Let me double check here. Yeah, it's 18. From my experience. Now let's pretend you didn't know that, right? Let's pretend you go and but you don't have to copy this. Let me go ahead and pretend I do 6. So it'll be like that, and then you might think 6 here. Let's pretend 6x, negative 6 times 1. But then you use a calculator, 90 divided by 6, you get 15. Now notice, if you look carefully inside the parenthesis, you can pull out 3. That means you're not done. And you can continue with the 3 if you want. Like you go ahead and leave the negative 6 there, but when you pull out, it's a multiplication. It'll be 3 here, the parenthesis, x minus 5, like that. Then you multiply this together, it'll be 18. Yeah, no kidding. Yeah. There you go. If you didn't do it, you didn't get the G set the first time. So I'll even keep it like that. But then I'll copy all this down. Oh, here we go. Oh, I didn't read the instruction. Solve the following polynomial equations under complex number numbers. If the answer, okay. So remember I mentioned earlier, if they don't match, that means you're going to flip the inside here. Remember that? Yeah.
Mm-hmm.
So the inner didn't match. Wait, actually, I'm going to go and do the 18. I know you copied this down, but don't erase anything. But I'm going to go ahead and do the 18, the actual 18 here. The greatest common factor for the last two is 18. So it's 18 x. I'm sorry, 18 times what will give you 36 is 2. Oh, my mistake. I don't know what I did. Can I go forward? No, I can't because I erased them. So anyway, yeah, if you did 6, I don't know what I did. Okay, it does match. So here, 18 can go on 36 2 times. 18 can go 95 times. I already checked it in the calculator. That's how I got that. Equals 0. Is that okay? Like that?
Yeah.
Yeah, but just think about what I did a moment ago. If you actually didn't get it, factor it again, pull it outside. It's supposed to work. So I think I made a mistake by factoring out the 3. I forgot to put the 2 to get the 6 back. Yeah, I forgot to put the 2 in there. That's it. Okay, this one. Now, once again, if this is common, write it one time somewhere in the front or in the back. I'm going to write it in the front again. One time. And then these two together in the back or somewhere in the front. But you got to write them together. There you go. Double check. Yes. Equals 0. Okay, here we go. And then continue. Solve. So you set each one equal to 0. 2x plus 5 equals 0. And then minus 18 equals 0. Now I think I made a mistake. Yeah, it's a plus here. Right, yeah. Oh yeah, 18 times what will give you, check there. Okay, 18 times what will give you negative 36. So it's 18 times 2x. 18 times what will give you in negative 90. So it's got to be plus 5. Is that okay?
Yeah.
There you go. So they have to match. Then you can copy it. They don't match, you double check your work. If they don't match at all completely, then switch this too. If they don't match. So like I said earlier, I think that my prediction is that they're not going to actually do that. They're not going to be that cruel to you to have you switch this. So, okay. So they're going to have to work every single time. If not, that means check your work. It's probably an arithmetic error somewhere. So that's my opinion there. Okay. Continue and solve. I think you see to subtract both sides by 5, divide both sides by 2. So it's going to be negative 5 halves. This one, add both sides by 18. So it'll be x squared equals 18. Then square root both sides. But I'll go ahead and I don't want to write that plus or minus. So it's square root of 18. Is that okay? I'll write it that way. That's how where I work. That's how I'm allowed to write it. But we're not done here because this is going to be equals to plus or minus. I'll go ahead and show the work here. 9 times 2 inside. But it's a perfect square for 9. Therefore, you can bring it outside. So final answer is over here. Plus or minus 3 root 2. Okay? Over here and over here. So yeah, you can list them like that, like negative 5 halves, comma, plus or minus. No kidding. You can write as compressed form like that. Root 2. Or you can write 1 plus 1 minus, comma, between them. So those are the answers. Okay, now same thing with this one. We're going to use the formula again. I'll rewrite it again. Now there is something here I want to point out just quickly. The instruction says this, but they don't have a problem that require you to do it. Let me show it to you right here. Not B, not even B. Oh, let me think. No, yeah, not even B. Yeah, not even B. But let me show you here. Solve the equation. Solve the following polynomial equation under complex numbers. There is no complex number coming out of it. But when is that going to happen? Well, I'm making this up. If you actually get one of the factors to be like this, pretend you work your way, and you get something on front, but one of them looks like this. I'm making this up. Plus 16. I'm making this up. There is no formula for a sum of squares. So what you're going to do is that you're going to set it equal to 0. The other one set it equal to 0 also, but I'm going to ignore that. I'm going to do this one. Pretend that one works fine. But this one, you're going to set it equal to 0, and then you subtract both sides by 16, and you're left with this. And here it is. This is the one that's going to turn into complex. It's going to be the I that's coming out of it, remember? So here's, if I continue being like this, then the final answer will be plus or minus I times 4, which is going to be plus or minus 4i. The 16 will give you the 4. I think you're okay with that. So this is the complex form of the answer. Don't forget, this is just an example. So I don't know why they say that and they don't give you the problem. I think maybe they intended to be that but they didn't write it correctly. Following polynomial under complex numbers. Yeah, there's no complex numbers here. Oh, I know. I'm sorry. I take that back. It's the B. Oh, but just in case this one also, okay? Just in case the A will be something like this. But the B, there is a complex. Oh boy, here we go. But we're going to use the formula. So this one is going to be a little long, but we have time. Take a look. We're going to do the formula again, but it's a cube, the difference of cubes. So I'll write it here. So it's A plus B, opposite here. Same. See, I don't really need that slope. I have it memorized, but for some reason I messed that one up. Same. And then you're going to do A squared. Can I erase this part? Let me see. Oh yeah, good. A squared, opposite here, AB, always plus B squared. Now this part, you're going to have to set it equal to 0 and you have to solve it. Watch, it's going to be pretty fancy. You're going to get an imaginary number coming out of SO for opposite and always plus AP. I'll capitalize that. AP. So you use this formula again. Here we go. So I'm going to write this the cube form of that, the A and the B. So I'll parenthesize that. Here's your A to the third. Minus is minus. It'll be 5 to the third. 5 to the third. Okay. Like that. Equals 0. So that means I'm going to write this part right here underneath here. Is that okay? Because we want to keep it equal to 0. So if I continue, my A is X. So I need space here. So it's going to be X minus 5. And then A squared, that's going to be X squared. Plus is plus. A times B is 5 times X. X times 5. Doesn't matter which. And then last one is plus 25 or B squared. So it's 25. That's your 5 squared equals 0. So far, okay? So continue on here. Then you set this one equal to 0. X equals 5. But this one, here we go. This is where it gets fancy right here. How do you even solve this? Because you're never going to... I have to say... you want to make a note here, okay? You have to make a note here. The last... Oh, man, I bubbled it. I should not have bubbled that. When did I bubble that? Okay, anyway. This here, I want to make... I have to point out something. The last factor of the difference of cubes. This is the first factor. The last factor right here can never be factored. This is not factorable. So you don't waste your time trying to guess the combination or X method. It's never factorable. Is that okay? Not factorable. Make a note so you don't waste your time here. Not factorable. So be aware. You got to know it, because if you don't, you might expend energy and time there. Don't do. Yeah, I don't want to do it. So you can erase that. Yeah, so it's not factorable. Yeah, make a note. So not factorable. Not factorable here. We're talking about the last term here. Not factorable. Okay. So don't waste time. So therefore, you're not gonna try to do something like this out of it. Okay. But I'm gonna copy the trinomial. But then how do you solve? Yep, you're gonna have to do quadratic formula. Do you remember that? So that means I'm gonna point this out. Don't do this. I'm gonna even emphasize by showing you this not factorable. So don't waste time. So if not factorable, how do you solve it? You're going to use the quadratic formula. Do you have that down? I'll rewrite it. Okay, so here we go. But then there's an I coming out of that even. Oh man, you're doing really fancy, complicated stuff here. How do I erase that? Okay, I think it's over here. Okay, let me try. Okay, good. Okay, all right. Quadratic formula. You have to use this one. So A equals negative B plus or minus square root of good. Have space. B squared minus 4 times AC. A times C in there, divided by all over 2 times A, 2A. So here's your quadratic formula. So you have to use this to finish it off. So you already got one answer. Careful, this is from the other problem here. Oh man, I make it even more messier. Okay, so you have to do this now over here. All right, so how we do it? So X, here we go, quadratic formula equals negative B, which is negative 5, plus or minus root of b squared, which is going to be 5. I'll write it before I simplify it. 5 squared minus 4 times a, which is 1. There's a 1 here, okay? You didn't see it. Times c, which is 25. Here it is. I can see it now that you won't get a negative root coming out of it. Let me, my eraser is too big here. Eraser. Yeah, and my 1 looks like a butt. I see. It's 4 times 1 times 25. Are you okay? So you follow, right? Okay.
Yeah.
For the quadratic. And then 2 times a, which is 1 again. So if you continue and clean this up, I'll write it. I'll continue over here. Okay, so we continue. Oh man, that looks warped. I'm gonna go downward. Okay.
Okay.
Yeah. I'll squeeze in here in my. Okay, so we continue. It'll be -5 plus or minus. Inside there, it'll be 25. Now, 4 times 1 is 4 times 25 is minus 100. Okay, you okay with that? No, that's a nice number. Over 2. If I continue one last step, well, not exactly one last step, it will be -5 plus or minus and -75. Here it is. This is where you're going to have to make an I out of it, too. Okay, now continue on. I'll go ahead and bring it down over here. If I continue on here, it will be -5, x equals. Okay, I'll give it x equals because it's still x equals all the way through. Plus or minus. Okay, I think you know a root of 25 is 25 times 3. I'll go ahead and jump a little bit, but there's an I. But if you're not sure, I'll add one more step into it. So it's going to be I. Actually, I will write final answer. It'll be 5i, but you got to tell me if you understand how I got it. If not, I'll do it on the side here. 5i, 25, 3. Actually, I'm going to write it. We have space. I'm going to write the whole thing. So if I clean this up, it will be -1 times 25 times 3. Okay, all over 2. One last step. Here we go. Very last step. -1 will be I. I'll do one more step.
Okay.
The 25 comes out 5, but the root 3 stays inside because you cannot simplify that 3 all over 2. And then you could stop right there if you want, like right here, but I'll flip flop. They don't normally write the I first, so I'll write the 5i root 3 over 2. Final answer. You don't have to split them. Now, had the 2 been a 5, then you have to clean it up. Divide everything by 5, imagine. But I'm glad it's not. So here's your final answer. You got 3 answers, okay? One, don't forget, 1 is plus 5 up here, and the other 2 are these here, complex. Is that okay? Let me highlight that. Yeah, so it's in red here. You got 3 answers. 2 complex, 2 I's, and 1 real. There you go. Yeah. All right. Is that okay?
Yeah.